So let's see, we can start the concept of matrix as a data structure that is used in R, that we can, R provides this one more data structure to you. As we know that matrix is a two-dimensional data structure and it is similar to a vector, but additionally it contains the dimension attribute. All
Jyoti ma'am,
attributes
can you
have,
please increase the font of it?
mm,
Matrix.
yes, yes, I will. Is it okay now?
Yes, yes.
Yeah. So all attributes of an object that can be checked with the attributes function. Here we can check the dimension also with the dimension function, and we can check the class. We can check the what class the variable is having, whether it is matrix or not. So if the class gives you the result as matrix, then it's a matrix. So let's see first how we can create the matrix in R programming. Uh, Matrix can be created using a matrix function. So this is inbuilt function. With the help of this function, we can create a matrix. Dimensions of a matrix, this can be defined by passing appropriate value for the arguments. These arguments are n row and n call. N row represents the number of rows and n call represents number of columns. By providing the value for these both dimensions is not mandatory, but we can set any of them or either of them or both of them as compulsory fields if we want. If one of the dimension is not provided, then the other dimension is inferred from the length of the data. So that is calculated automatically. For example, let's say if suppose I need to create a matrix which contains 9 elements, and instead of actually specifying the data like one by one, 1, 2, 3, 4, and so on, I'm just I'm just using a colon operator so that I can directly set the values to the matrix. So let's see how it works. So this is the command that I'm using, matrix, and in bracket that is arguments I'm passing as three arguments I'm passing. First argument specifies the elements, which are the elements that belong to the matrix. Second argument is for number of rows, how many number of rows I want. And third will be the number of columns. So I have specified here the dimension as 3 by 3. So accordingly, I have provided the arguments. So this is how the matrix is created. If we want to see the contents of this matrix, then we can assign some value. Let's say like at the we can assign these contents to some variable. So let's say this is a is equals to, I am assigning, and this is my matrix. And if I want to check the contents, then I will type a. So this is the my matrix will be displayed. So this is simple creation of matrix in R. Same results can be obtained by providing only one dimension, as we mentioned that any of the dimension can be mentioned or we can skip that one as well. So this is how we can do. Let's say I want to specify only the number of rows, then by default the remaining elements will be considered to create the column elements. So I have specified the 9 elements I want in sequence from 1 to 9 with colon operator, and number of rows I am setting, so this is 3. So this is how it is created. Let's say what will be the result when we set the ncall value only. So I'm setting ncall argument as a 3, and let's check what we get. So the same results I will be getting. Let's check the ncall as, let's say, 2. So now here we get error that because the whatever the number of elements we are having, that is not in a sub multiple of or the multiple of the number of rows. So it should be the number of rows or number of columns that we are specifying, it should be in sub multiple of your number of elements. So here, now if suppose I'm just I'm just changing the elements, let's say from 1 to 10, and number of columns I'm specifying as 2 now. So here, now, successfully matrix will be created for 2 columns, and for remaining elements, the number of rows will be created automatically in R. So this is how we can create a matrix. So this is the simple way of creation of matrix. We can also create a matrix. We can see that the matrix is filled column wise. So this can be reversed as well. So instead of filling the matrix as column wise, we can set it as row wise filling as well. Here, to do this, we have to set the arguments that nrow and ncol as true or false, whatever we want. So let's say I want to fill the matrix row wise. So this is the way how I can do it. I'll clear the screen. So the same matrix, I want to just fill by row wise, and the number of elements I'm considering as 9 and number of rows are 3, let's say. So here I can see if I just try to change the elements, or let's say now I am setting n like by row column is equals to true, and I have not specified any of the entry for nrow and lcol. Let's see how it works. So by default, as I have said, the by row is equals to true. So all the 9 rows will be created and elements will be filled row wise. And if we say that now by call is equals to true, then the elements should be filled column wise. Wait. I think only we can specify that. I have not checked that whether it should be whether it is working for n call is equals to true or by call is equals to true. But whatever data I have searched on the net, that if we want to set the elements into the matrix row wise, then we set by row is equals to true always. If you get any other like if we can set whether it should be filled column wise, like by default it is filled column wise, but if we want to fill it row wise, then we always set by row is equals to true. That's what I have read on the internet. So if I try to set by call is equals to true, it will give me an error. This was the thing for creation of matrix. Okay. And now, uh, so here a matrix is stored in column measure order internally, as we have seen this. It is possible to name the rows and columns of a matrix during the creation by passing here additional two elements. So this will be your list to the argument dimension. So here, if suppose if I want to specify, let's say columns should be named by letter, let's say A B C, and rows should be represented by letters X Y Z. So I have to create a list to represent those column names and row names, and we have to pass this list as the argument to the dimensions, that is dim names. So this is the attribute of matrix function. Let's see how it works. So this is the command. Shall I specify the commands in chat box for you to execute?
Later on, you are going to share this file with us.
Not required because you have already shared the link na, with us.
Yes, yes. I have
Yeah.
shared the link. Yes.
Hmm.
Okay.
Okay.
So this is how I am specifying elements, then n row I have set, and here I have just made, I have passed one argument, that's dim names. So this is the argument that I am setting in the form of list. So list will, I will have to create a list for row representation and column representation. So I need to create a vector first to represent the names, and then I will combine those names into a list. So that's why I have used list function. And for list function, I'm passing the arguments of two vectors, one for row and other for column, as you can see it on the screen. So this is my command. It becomes, so X is my matrix. If I now see the contents of X, so here I will get, so these are my columns A, B, C, these are named, and rows are named by X, Y, and Z. So any name that you want, you can specify in the form of arguments when you set to dim names. So this is one thing that you can work with names. Now, if I want to access the names what I have given, so I have the function call names and row names. So whatever call names I have set and row names I have passed through these dim names. So I want to just display it. So I will call one function which is named call names, and I will pass argument of your matrix variable. So I'll just pass, I want to display column names. So I'll call names and argument is X. So this will display what names I have given. Similarly, if I want to print, let's say, what are the row names that a matrix X holds. So this is the command that row names in bracket X. So this will display your rows. It is also possible after creation of matrix, if I want to change the names, this ABC into some other names. So this is also possible. So we can set new column names and new row names by simply assigning and creating a new vector. So let's say I want to, instead of having ABC as column names, now I want to I want to rename those as by C1, C2, and C3. So I will create a new vector for C1, C2, C3 elements, and I will set these two. I will assign this vector to call names of X. So this is the command that I will do. So call names of X is equals to, I'm creating a vector with C1, C2, and C3 elements. So this is the command. Now, if I see what are the row names and column names for this X, so this will be displayed. So my call names are now renamed. The same thing you can do for renaming your rows as well. To rename the rows, I have the command row names of X is equals to create a vector and pass whatever elements you want to use for naming the rows. So I want to rename this XYZ with R1, R2, and R3. So this is how I have created a vector and I have simply assigned it to row names. So this was the command. And now if I see what X represents, so here X will be denoted with column names C1, C2, C3, and rows names as R1, R2, R3. So this is how you have simply created a matrix and renamed its columns and rows. Let's see next concept, that is matrix metrics. Once you have created a matrix, I would like to know what is the dimension of matrix, or how many rows are there, or how many columns are there, or how many elements are there in matrix. So these are the few questions that we always need to deal whenever we are dealing with data science or any data that we have extracted from the internet or source. So let's see how we can see the dimensions of a matrix. We have seen that we have directly used the colon operator to create matrix elements. So whenever we know that the matrix contains some sequential elements from 1 to 9, 1 to 10, 1 to 100, whatever. Now I want to explicitly define, or I want to explicitly set some elements. So if I know exact what elements I want to specify, and that is a random data, so I can pass those elements in as an argument to a create function. Let's see first how we can do that. So let's say I want to create a 3 by 3 matrix which contains a data that is passed in a vector form. So here, and I want to set number of rows as 3 and columns as 3, and I want to set that data should be filled row wise. So I have set by row is equals to true, let's say. So this is what I have done. So I want to create a matrix of elements 1, 2, 3, and I have to specify, like I have to hard code it. So I have used these elements as an argument to create function. So this is mandatory thing whenever you are setting explicitly values to the matrix as elements. So you have to use this create function always. Create function is nothing but you are specifying some elements together to be combined. That the create function is basically used for, and it always creates a vector. So this is, I have set the matrix elements. Now if suppose I want to print the contents of this element, this matrix, so there is a function cat. So I'm using a cat function to display some string on the screen. Let's say I want to display the words like the 3 by 3 matrix. So whatever I want to display or to be appeared on the screen, that I will pass as an argument to cat function in double quotes. So this is my command. That is when I want to work with displaying something on the screen. So I'm using a cat command. There are other functions as well. So this is how the message is displayed as the 3 by 3 matrix. Now if suppose I want to simply print the contents of A, so I'm using a print command. So this is one more way whenever you want to work with displaying something on the screen. So here the matrix is printed over here. The difference between the cat and print is like, let's say cat stores nothing but print A. If I, let's say, try to do something like, suppose D is equals to print of A, and if I just type D over here, so whatever I am passing to print function, that will be stored in a D. But instead of cat, we like if we try to assign something to D is equals to cat of, let's say what it was the message. So let's suppose, or something, anything, let's say any value just I'm setting. So we are just saying what is the difference between print and cat. So now if I just check the contents of D, so here nothing is assigned to D. So like cat say internally nothing is assigned to D. Even if we try to assign that value that is written by cat, is actually null. It stores nothing. But in case of print function, it stores whatever we have passed. So storage is there is a storage requirement for print function, and for cat there is no storage. So whenever we are dealing with just we want to print something on the screen and it is of no use later on. So in that case we can use cat function. Otherwise you can go for the print function. So now here I have just used this cat and print function just to denote what is the usage of this. Let's continue with seeing the dimensions of matrix. Now I want to see, or I want to check what is the dimension of whatever matrix I have created. So here I will use dim function, that is dim, and I will pass whatever matrix I want to check the dimensions for. So here I have created a matrix A. So I will pass this matrix as an argument to dim function, and I will also have to print whatever dimension is written by this dim function. So this will be working now as an argument to print function. So I have used print function and argument is dim of A. So this is my command. So the dimensions 3 by 3 is displayed as we have set n row is equals to 3 and n col is equals to 3. So that dimension is displayed. Now I want to just check, or I want to print what is the number of rows. So I will call print function and I will pass the arguments as n row of A. Or even if I just do n row of A, so it will just give me what is the number of rows that the matrix A is having. So similarly, if I do n col is equals to, or n col of A, then it will give me the number of columns that are available for R, for matrix A. So this is how we can see the dimensions. Okay, we have seen the
Jyoti
dimension
ma'am,
that is,
can you please share this code or the link of this code?
I have shared, ma'am. I have shared those two links na in the chat box.
Uh, but this example that you are showing, I guess that example is not there in those links.
Both links, it's not there.
एक
Oh,
second. Let me check it again because I
be-
couldn't find it.
okay, because I will also have to check because this documentation was created long back, ma'am, last year. So I don't know exactly the source. I just have mentioned wherever
Uh,
the data I have taken now. So in the link form. So for the documentation that I'm having, so it
yeah,
is
yeah.
mentioned these two
It
links.
is only about just till printing the matrix. This code
Okay,
is there, yeah.
okay. I'll just check and share, ma'am. Otherwise, if it is not there, then I will just provide you the documentation as well. No problem.
Yeah, I found that the programming, the second link, gigs for gigs.
Yeah, it's there, na?
Yes,
Yes.
yes.
Because the documentation I have created, na, so I have just I mentioned whatever links I have referred. So for that respective portion, it's there.
Yes, okay.
Okay, fine. So we have seen how we can see the number of rows and number of columns.
So I just want to know that if I want to create a program in R instead of doing all these commands separately on the console.
Hmm.
So what has to be the program extension? Dot R.
Uh, yes, .r. So we have to create a script file for that.
Okay, okay.
Yes.
This code that you are currently showing us that we can do in the R script, right?
Yes, yes.
Console.
I'm going to cover that how we can create a script file later on in third module.
Achha,
Till
okay,
then, I will be just showing how we can use these commands.
okay, okay.
Okay. So now let's say I want to check how many elements a matrix is having. So I have a function in R that is length. So if I pass the matrix name as an argument to length function, so this will give you how many elements are there in a matrix. So whatever data I have created, like whether it is a vector, whether it is a list, or whether it is a factor, if we pass that object name to length function, it will give you how many elements are there. So for a matrix, it will give you how many elements are there in a matrix. That is 9 elements we have. So this will display accordingly. Or we have other function as well. That is, we have prod function and whatever dimensions we have. So we have dimension as 3 by 3. So this dim function will return 3 by 3, right? And if we use prod function, and this will take the arguments that are written by dim function. So product will calculate the product of it and it will return the number of elements as this one. So this is another way to find out what is the dimension or what is the number of elements a particular matrix is having. So these are some ways we can work with. So this is how we have just seen the simple matrix creation and looking at the dimensions of matrix. There is another way also to create a matrix. So R provides two functions, that is cbind and rbind. So we will see how a matrix can be created with the help of these functions. So this is another way of creation of matrix. Cbind will take input as a vector, and whatever vector you have passed as an argument to cbind function, these arguments will be used to create your matrix. So here I am specifying the arguments in first vector as 1, 2, 3, and in second vector as 4, 5, 6. So I'll have to use the create function first so that it will create a vector of these elements and then it will combine this into a matrix. So this is how we can do. So cbind, and it will take two arguments. So this is one argument and this is second argument now. So this will create these values for you, this matrix for you. Similarly, we are now having the r bind function. सी बाइंड से होता सी बाइंड मुळे होतं काय की जे काही आपण व्हेक्टर्स पास करतोय ते कॉलम बाय कॉलम आपल्याला क्रिएट करता येतील. म्हणजे फॉर एक्झाम्पल फर्स्ट वेक्टरचा फर्स्ट एलिमेंट अँड सेकंड वेक्टरचा फर्स्ट एलिमेंट, सो दॅट विल बी प्लेस्ड इन कॉलम्स. So 1, 4 will be placed in columns. Then in next row, 2 and 5 will be placed. And then in next row, 3 and 6 will be placed. So this is how we are filling the matrix by column elements. Now let's say I'm using rbind function and the same arguments I'm passing. So this is how now the matrix is created of size 2 by 3. So here now with row bind, whatever elements you are passing, that will be placed in rows first, like first element of first vector and second and first element of second vector in first and second row likewise. So this is the different with the help of cbind and rbind, but both functions are used to create a matrix anyways. Same functions that we have seen previously to see the dimensions, this will work for this as well. For example, let's say I'm just creating now d is equals to, or I'm just assigning these values, these elements to a matrix denoted by, let's say, d, and d is equals to, let's say I'm setting r bind. So this is, I have created a matrix, and if I have seen, if I just type d, so the matrix will be displayed. And now I will simply use the previous functions like length or n call or whatever we have seen. So the same thing now replaced with d as argument, so you'll always get the same results. So this is only the second way of creation of matrix with the help of cbind and rbind functions. There is another way also to create a matrix from a vector by setting its dimension using dim function. So now let's say I have the vector from elements 1 to 6 and I have specified it is x is equals to c of 1 to 6, let's say. So this is a vector. Now I want to convert this vector into a matrix. So let's first check what is the class of this vector that we have created. So we get this numeric, but now I want to convert this numeric vector into a matrix. So R provides the function dim, and whatever vector we want to convert into a matrix, that I will pass as an argument to the dim function, and this will be assigned a value of now how many columns and rows I want these elements to be converted into. So this is the syntax to do this. So dim of x is equals to c of 2 comma 3. So here a matrix of size 2 rows and 3 columns will be created for the elements that you are passing in this x. Now if I just print what are the contents of x, so here you can see the matrix, you can see the matrix is displayed. Now unless and until I'm just checking this whether what is the class of this x, I am not sure about whether it is a matrix or not. But as we have said, this dim x is equals to create like we have specified these elements to be stored in the form of matrix with the help of dim function. So class of x will give you now matrix, and which is in a array form. So this is the difference between when you are simply specifying the vector elements and you are assigning it to x, and if you try to display class of x, so it will give you numeric. But now when you are specifying this vector as an argument to dim function, then it will be created into a matrix. So these are some ways that how you can create a matrix in R. Let's start with the another concept now, how to access the matrix elements. So there are basically three different ways in which we can access the matrix element. First way is using integer vector as an index. This is one way. Second way is using logical vector as an index. Third way is using character vector as an index. So we will see what are the various commands to do that when we want to access the matrix elements. I'll clear the screen. Okay, so we can access the elements of matrix using square bracket, that is indexing method. The elements can be accessed as var of row comma column. Here, the rows and columns are nothing but your vectors. So the first way of using integer vector as an index, how you can access the elements, we'll see that. We specify the row number and column numbers as a vectors and use it for indexing in using integer vector as an index. So any if any field inside a bracket is left blank, so it will by default select all the elements and it will display. As when we are dealing with printing of matrix elements, like simply we are typing the name of the matrix, so it will by default consider all the elements and it will display. But now if I want to specify some particular elements, so I will just specify its indexing, that we usually do. So here, let's see what are the various ways we can access the matrix element. Suppose I want to select row 1 and 2 and columns 2 and 3. So this I have specified as a command. So I have specified first row, second row, and first row and second row, and columns second and third. So this I am providing in the form of vector. So the first elements over here, that C of 1 comma 2, here it will select row 1 comma 2, and the second argument over here, that is C of 2 comma 3, it will select the columns 2 and 3. So this is one way to access the elements. So this is how you have displayed first row and second row and these columns, respective columns. Is it okay, ma'am? Is it clear to you?
Yes, yes.
Okay. Now, if suppose I want to simply specify here, like I don't want to specify the column field. So if I do this, like I have simply specified the row numbers, like row 3 and 2 I have specified, but I haven't denoted any column. So let's say I have specified third row and second row, and column field I have kept blank. So by default, it will select entire columns for these row numbers. So this will display like, just a minute. You are getting the same error at your end, or I missed something? Okay. Let's say check with 2 and first. It's out of bounds, so I'm trying to access the elements that are not present. So this is how, if I specified second row and first column, second row and first row, so this will display your input, your output, like 246 and 135. You can just check it over here that I have the matrix elements. For previous X I have, shall we do it again with creation of matrix element, then we can cross check.
Yeah, I'm also getting the same error.
Okay, because we have created so many matrices, so dimensions also have been different. Okay, let's check with this matrix. Suppose this is our matrix X. This has the elements 1 4 7 2 5 8 3 6 9. Now if suppose now we check this command, so we are passing first row, second row has to be displayed for the columns second and third. So our output is now here. See, first row and second row for second and third column. So 4, 5 and 7, 8. So these columns will be displayed. Now similarly, for if we just don't specify any column field, so here we are trying to access third row and second row, and we have not specified any column over here. So all the columns for third row and second row will be displayed in sequence. So this is how third row we have 369. So this entire third row will be displayed, and after that we have passed 2. So second row will be displayed later on. So 2, 5, 8. So whatever sequence you specify, that will be displayed in the form of vector. So this is how you can use integer vector as an index. So you can set the rows, you can set the columns, or you can skip specifying any row or any particular column. So whatever you have skipped, by default, it will be considered to print as entirely. Is it okay, ma'am?
Yes, yes.
Okay.
Yes, ma'am.
So similarly, if I now skip both of them, so I'm just simply typing X of and blank indices. So it will display the entire matrix. So there is no difference in simply typing X and passing null arguments. So it will display the same thing. So this is way we can access the matrix elements. There is another way to access the matrix element, like we want to skip particular row or skip particular column with the help of negative indexing. So if I do X of -1, so it will select all rows of matrix X except first row. So this is how it will print. So X of -1 and column I have kept as blank. So this will skip first row, so it should print 258369. So this is how you are getting the result. So similarly, if I skip specifying the row index, and now I want to skip the second column, let's say. So I'm doing -2. So X of first index blank and second as -2. So it will skip second column and it will print everything. So second column we have as 4, 5, 6 is my second column. So this is skipped. So we get 1, 7, 2, 8 and 3, 9. So this is how the negative indexing will skip a particular element. So here one thing to notice is that if the matrix returned after indexing is a row or a column matrix, so this will be always treated as a vector, that we can see with some example over here. Let's say suppose I am doing X of 1. So it is like we are creating a slice of that particular matrix. Hence, it is created and it is stored in a vector. And if we see here now the class of, just to cross verify whether it is a vector or not. So I'm just using class of X of 1. Second argument blank. So it will give you integer. And if you see the class of X, it is a matrix actually. But whenever we are creating a slice, it is converted into a vector, and that to integer vector. So this is the how you can access the matrix element with slicing. And what is the meaning of creating a slice? So whenever you are trying to access a matrix elements, it is always considered as a slice, that we have seen for list also. Okay. Now, as we have seen that whenever we are creating a slice, it is converted into an integer vector. So we want to avoid this, let's say. So whatever slice we are creating, that should be also of a matrix type, if we want that thing. So this there is one way we can set the drop argument in indexing. as a false. So this will just nullify the effect of creation of matrix. So this is how we can set the argument in an index. This is the command x of, we are passing a row, then column blank, and we are setting drop is equals to false. So this will be now whatever slice we have created, instead of creating it in a vector, it will be of a matrix type only. So if we check this, what is the class of x of 1 over here? Sorry, we have to specify the drop as false also when we are checking the class. So here now it will be a matrix. So the use of this will be just storing whatever slice we have created in some variable name, and then we can just access it whenever we want. So that will be in a matrix form. So that was about accessing the elements. Okay. There is another way. While indexing, we can just use the colon operator as well. For example, let's say I'm doing x of 1 to 4. So this will give you a vector of the four elements, that too first four elements. Like suppose we have our matrix X as it is this 1 4 7 2 5 8 3 6 9. So these were our elements. So if we do x of 1 to 4, so it is giving you this 4 6 1 and 8. We'll just check it with fresh example. I'm not able to just track what elements it is printing. It's simply creating a vector from elements 1 to 4. It's not about your matrix actually. If I'm specifying x of 1 to 4, it's directly printing the all the elements from 1 to 4. So it is like it is creating a new vector and it is assigning to x only. So this is the one thing that while indexing you have to specify both the arguments either separated by comma only. But if you specify it separated by colons, then it will directly consider that these elements have to be created from 1 to 4 and it has to be assigned to x. So this is the meaning of x of 1 to 4, even if you have created previously x as a matrix. So this is one important point about when you are dealing with matrices and vectors. So this is because simply the columns will be created, that to four columns will be created and the values will be assigned from 1 to 4. So that is like a stacking of columns one after another. So it is simply treated as a vector here. Okay, let's see another point, that how we can access the matrix element with logical vector as index. I'll clear the screen. Two logical vectors can be used to index a particular matrix. So in this situation, rows and columns where the value is true is written. So here like the indexing vectors are recycled if necessary and they can be mixed with the integer vectors. So let's say we have a matrix like 4 8 3 6 0 7 1 2 9. We'll just create a matrix first for these elements. So let's say we are creating these elements. That is 4, 8, 3, 6, 0, 7, 1, 2, 9, and we will assign this to dim function. So for these elements, I have created a matrix. So let's say this is my matrix. So now, if suppose I set the logical indices to represent rows and columns, so this will be like the first vector is to represent rows and second vector is representing the columns. So for this, I am setting true. That means first row we are considering, then second row is set as false, so we don't want to print the second row, and third row we want, so that is set as true. Similarly for columns, we want first column, we want second column, and we don't want to print third column, so that's why it is set as false now. So this is how I'm simply using the logical vector as index. So let's check what it prints now. So from this input, first row we want, so first rows, first element we want, that is 4 is printed. Then first row and second column we want, so 6 is printed. Then first row we want and we don't want the third column, so 1 is skipped. So this is how we are simply printing 4, 6, 3, 7. You got this, ma'am?
Yes.
Okay. Let's see now how I can use logical indexing along with your integer index. So you have that possibility as well. So this is, let's say, command. We have passed in one vector your logical indices and in second as integer indices. So here we want to print first row, we don't want second row, and we want second column and third column. So this is how I'm using the command now. X of c of true comma false, and another vector is c of 2 comma 3. So this will give me the first row, and we don't want second row but we want the third row, and from these elements I want only second and third column, hence 6, 1, and 7, 9 is printed. So this is how you can access the elements. So in there is another way. Instead of always passing the two vectors, we can pass a single vector also. So this is like I'm simply specifying. So this is, I want to just print first row only. So this will simply create a vector for these elements. So you can just relate what output you are getting from your input. So this is first row I want. So this is 4. Then I have third column I will get because I haven't specified anything for your third row. So third row ke elements I will get. Then so this is about just logical indexing. Okay, we can use some kind of conditions as well. So if suppose I want to simply print whatever are the elements that are, let's say, greater than 5, and I want to print it from matrix. So I can just specify x of x is greater than 5. So it will simply print all the elements which are having the value greater than 5. So we can use conditions as well in the form of indexing. So let's say suppose now I only want to print only the even elements. So this is how we can use it while indexing. So x modulo operator I will use. So this will simply print all the even elements from your matrix. So this is how you can use the logical indexing to access the matrix element. Let's see third part from the matrix, that is how you can access the elements using character vector as index. So at the time of indexing with character vector, it is only possible when we have specified the row names and column names. So unless and until we have that vectors with us that we have used at the time of creation of matrix, we can't go for using character vector as index. So let's say suppose we have already created the matrix with names also. Let's specify something. I'll just use previous code only. I need to find it out. Let's say suppose this is I have created. So I have given names. This is my matrix. So let's see now how we can use the character vector to access the elements as index. So if I have, let's say I have just specified the column name, what I want. Let's say I want to print the elements from column A. So I will just type like x of the row I am keeping blank because I'm not concerned with which row I want, but I want all the elements from column A. So I will just type x of blank comma A. So this will print the all elements for this column. So 1, 2, 3 will be printed, that too in a vector form. Ma'am, wait a minute. I'm just getting a call, I guess. Somebody's waiting in waiting room. Oh, okay. We'll continue. Fine. So we have seen how we can simply print all the elements of a matrix for a particular column. So in the same way, we can specify row name as well. So let's say I'm simply typing X over here. I want the elements from X row. And the second is I'm not concerned with which column. So all the elements for X row will be displayed. Okay, so this is how all elements for X row will be displayed. We got error previously because I used a small x over here. And at the time of creation of row names, we have given capital X. So this is one care that you have to take. So we have seen how we can access the elements by specifying row names and column names. Let's say another way. Suppose I have simply combined this character names as indices with logical vector as well. So this is one way that we can set. So I'm concerned with specifying, like I want to display all the rows, like all the row names I want to display. So I will simply specify true over here as a first argument of while trying to access the access elements. So first index is set as true, and for second index, now I have specified I want to extract the elements only for columns A and C. So I will get here all the elements of column A and C, and all the rows X, Y, Z will be displayed. Let's say suppose I have simply specified now I want all the rows but only for A column. So this is, I will get A column only. Now suppose I am just specifying, this is one another way where I am using a colon operator from 2 to 3 now, and I want the columns A and C. So I should get these elements. So this is how your indexing for integer vectors and character vectors will work for. Is it okay, ma'am?
Yeah, yes.
Let's start with another concept. Let's say now we have seen how we can access the elements as well, dimensions as well. Now let's say I want to modify the elements. So with the help of first trying to access the particular element, and then we can specify whatever assignment we want. So it is like we are using indexing. You can either go for vector indices or integer indices or character indices. So here, let's say suppose I have tried to access a particular element, that is second row, second column, and I have specified assignment as 10. So the second row, second column's element will be modified by 10. If I try to check the contents now, so that will be modified element. Initially it was I guess 0 or 5 something. So it is changed. So in the same way that we usually do with C or C++ or any other language, here also we are doing the same thing. Now, if suppose I want to modify all the elements which are, let's say, having the value less than 5, and I want to specify the assignment with 0. So this is how we can do it. So I'm just doing x of x is less than 5. All the elements of this matrix which are having the value less than 5 is to be assigned a value as 0. So this is the command. If I try to check the contents of x now, so all the elements will be set as 0 which were having the previous value as less than 5. So at a time, if I want to do some modifications by specifying a particular condition, so that condition can be used as a index, and we can set the modifications. There is another operation whenever we are dealing with modification of matrices. We generally go for transpose. Like many times, we want a transpose of a particular matrix. So we have a T function, that is T of whatever argument you specify. The transpose of that matrix will be calculated and it will be displayed. So this is the T of, let's say, X. So transpose of that matrix will be displayed. So rows are converted into columns. So that interchange operation is done. Okay, we can also modify matrix elements by using cbind and rowbind function. So we have seen that how we can use cbind and rbind functions to create a matrix, right? So similarly, now I want to change a particular row or a particular column. So I will use respectively cbind or rbind function. So this will simply, whatever elements you are specifying now for that particular matrix, so that vector will be considered as an additional vector to be combined with previously created matrix. So let's say suppose we already have this matrix. Now we are considering Okay, let's see first what are the contents of X. So this is our input matrix, let's say. And now for this matrix, I'm trying to add one more column. So we are using cbind function. So now here the two arguments will be, the first argument is your input matrix for which you want to add the new column, and the second argument will be now the elements that are the new elements that you want to add as a column. So that is specified as you have specified cbind. So this will be adding this input of elements as a new column to X matrix. So this will add a column that you can see that at the end 1 2 3 is appended. So with the help of cbind, you have added a new column to previous X matrix. Now, if you want to modify the matrix elements by adding a new row, so I will use rbind function. So rbind, and the same syntax I'm using. So this will add 1 2 3 as a new row to the previously created X matrix. So this is what about modifying the matrix elements by adding new rows and new columns. We also can remove a particular row from the matrix. So let's see what command is there. So this is the command that we have simply we have specified X of 1 to 2. So we have specified the first two rows has to be assigned to the matrix X. So it will directly remove the third row, that is the last row that we have, and now it will have only the first two rows elements as matrix elements. Is it okay? So third and fourth जो भी है वो remove हो गया, and the contents, the first row and second row will be displayed. So this is about the matrix modifications. We have seen how a matrix dimensions can be set, and how we can create a matrix with dim function. So with the same dim function, matrix dimensions can also be modified. So we will see that. So we have X now as, let's redefine X. Let's say suppose this is our input matrix, and now I want to modify the dimensions of this matrix. So we have the command that we have set, we have used this command previously at the time of creation of matrix by specifying the dimensions. Now if suppose this input matrix X is of 3 by 3, so it is having 3 rows and 3 columns. Now I want to just change this to, let's say, 1 by, let's say, 9. And if I now try to print X, so it will give you the the same matrix with new dimensions. So this is how the matrix is modified. So whatever dimensions you want to change for previously created matrix, you can specify. Let's just check now. Instead of 9, let's try with 1 and 6 whether it will work. It won't, because whatever elements we have, that we have 9 elements with us. So whatever dimension you are giving, that should match with the length of that matrix should match with the number of elements we are having. So that care has to be taken whenever you are trying to modify a matrix with the help of dim function. So that was about The matrix elements modification. Okay, so that's all about matrices. We'll just take a break of 5 minutes, ma'am.
Yeah, yeah, sure.
Okay. I hope you are doing these commands at your end.
Yes, yes.
So we have covered data structures, vector, list, and matrix. Now two are remaining. I'll just have some water. I was just looking whether that second documentation is having some different examples. Okay, we'll try to start with a new data structure, that is factors. For factors also, for this data structure also, I have considered the same link that I have given you already, that is gigs for gigs. So factors are nothing but these are the data structures which are implemented to categorize the data or to represent the categorical data and to store it on multiple levels. So they can be stored as an integers or strings as well. But whenever you are creating a factors of strings, and if you are using them as integers, so you have to do some you have to just take some care, because strings cannot be converted into integers. So you have to create some labeling according to whatever integers you are representing. to denote some string. So that has to be unique one. Though factors may look similar to your character vectors, they are integers as well, that if you have specified some labelings. The factors accept only some restricted number of distinct values. For example, a data field, let's say denoting information about gender. So it may contain the values like male, female, or transgender. So that's why we are saying it as a restricted number of distinct values. So we use whenever we want some data to be represented in the form of levels. So we always use factor to denote this kind of data. Factors are having some attributes like it is represented in a vector form. So whatever data you are representing, that you want to convert it into a factor. It has some levels, so it is having some set of distinct values. So how many distinct values it is having, that denotes your number of levels. Labels is nothing but it's a character vector that corresponds to each label. It is a ordered set of elements in the form of this is like a logical attribute that is deciding whether the levels are ordered or not. Then it has a value as n max, so it will decide what is the upper limit of the maximum number of levels. For example, your data related with gender, so the upper limit will be 3 over here, so n max will hold the value as 3. Likewise, so we will simply see some points about how we can create a factor and how we can use a factor here. So let's see what are the commands and syntax for that. I'll just clear the screen. You are able to see my screen now, ma'am?
Yes.
So this is the command when I need to create a factor. I'm using a factor function. So this will be my command only. So this will specify whatever argument you specify to this function. It will create a factor for you for that particular elements. So let's
Can you
check now.
send this link?
I have specified, ma'am, that gigs for gigs.
Okay, so we need to explicitly find it. Okay.
No, I will share. I'll just give. I sent it, ma'am.
Yeah, okay.
So let's see how we can create a factor. So first, I need to create a vector for the elements. So I will use my C function, that is combine these elements into a vector. Now for this elements or for this vector which is having the elements, these 4 elements, I want to convert this vector x into a factor. So let's say I'm giving some name to that created that factor I want to create. So let's say I'm specifying gender. So this is a name I'm using. So the gender is assigned factor of x. So now whatever elements we have in x, that will be converted into a factor data structure and it will be stored in a gender object. Now if I try to see the contents of gender, so it will display you whatever are your elements and whatever are the levels. So here you are having only 2 distinct values as female and male. So these whatever distinct values you have, that will be treated as levels. So that is about factor creation of factor and displaying the factor elements. Now, if suppose I want a programmer should specify the levels for the data. So we have the argument that is we are setting with factor function. So that argument is levels. So we are setting a vector of elements to levels. So levels is equal to whatever vector we are specifying, that will be our levels for a particular factor that we are creating. So here we are creating a factor of 4 elements: female, male, male and female, and we are now setting the levels as female, transgender, male. Even if the element is not there in these 4 elements, like female, male, male and female, only these 4 elements are there. But at the time of specifying the levels for a factor, now we have added the third element, that is third distinct value as transgender. So this is possible when we are creating a factor. So whenever we are by default, whenever we are displaying a factor
Jyoti
without,
ma'am, can you please repeat what is the difference between factor and vector?
okay, factor will give you the elements along with its levels, like how many different individual levels are there. But for vector, it's only a set of elements. Factor is also having a set of elements, but in additionally, it will give you the information about how many distinct levels are there. Okay, ma'am?
Kind of levels, I mean, I didn't get.
Levels, okay, we'll just see, ma'am. Okay, let's say suppose that previous example. Okay, suppose I am specifying here x is equals to C of 4 elements I have specified: female,
Hmm.
male, male, female. So
Hmm.
there are 4 elements. If I try to display over here x, I get these 4 individual elements.
Hmm.
So this is not a factor. But now I want a factor which represents some categorical data.
Hmm.
So here the categories for this kind of vector is having only 2 categories, that is male and female. Right.
So
So
does the
I,
level mean a category?
yes,
Okay.
level means the number of distinct values. So this is
Hmm.
what the categorization I'm specifying, like classification kind of thing.
Hmm.
So
Okay.
now I can, now I want, instead of creating a vector data, I want a factor data, that is categorical data. So
Hmm.
I'm using a factor function. But now here I want to, I have to specify which elements I want to be a part of a factor. So
Hmm.
that's why I'm using these elements by in the form of a vector. Let's say first I will have
Hmm.
to create a vector for those
Hmm.
elements, then I will have to convert it into a factor. So
Hmm.
that is the only way that we can create a factor.
Hmm.
It is a two-step process.
Yeah.
Okay,
Yes.
now so by default, if suppose, let's say now create a factor first. So here for this data, you are able to see my screen now.
Yes, it's
So now
visible.
for this data, I want to create a factor. So I will assign some name, let's say gender. So gender is a factor data that I'm going to create. With this command, I will create it. So if I now just type gender over here, so this will give me the elements along with levels it has. Okay, so by default, it will identify what are the distinct values and it will print for levels. But now, uh, as we know that there is a third level also, that is transgender. So I want a programmer or a user to specify how many distinct levels that a particular factor should have. So I can set levels argument inside a factor function. So I'm just using this command now. So I'm specifying second argument. So here I have specified second argument for factor function. First argument will be my vector, that is elements I want to be converted into factor, and second argument is levels. So levels will be again your vector only. But now this will be, you are simply creating a vector to represent levels that factor should have. So that's why I'm setting levels is equals to whatever vector you have created. Now if I try to print what factor gender contains, so now this will give you three different levels. So that's what the difference between using levels argument and without using levels argument. So this is how you can predefine levels of factor. Okay. If I want to check whether a particular data is of type factor or not, so there is a function is dot factor. So this will return you true or false. If your input, whatever you are specifying for this function, I'm passing this gender. So is dot factor will return true or false depending on whether gender is a type factor or not. So we have created it initially, so it's giving us true. Now suppose I'm simply giving x is equals to that I have not created a factor. I'm simply specifying x as a number of elements, different elements in the form of vector. Now if I check whether this x is now factor, so it will give you false because we have not converted this into a factor. So this is how you can check whether a particular vector is representing a factor data or not. So that was about checking of factor. We also can display like there is another way also whether a particular data is factor or not. So we can use class function as well. So here if I just check whether class of x, we can just display class of x. So here it represents character. Now let's say suppose create this factor and now use class of gender. So it will give you factor. How to come out of this?
You can try for Control Z.
Control Z. Yeah, thank you, ma'am. It will come out of R. It has come out of R, so I will have to again specify. So this is another way that you can check whether a particular object is a factor or not using is dot factor or class function. Let's see now how we can access the elements of a factor. So with your indexing, like the same way that you are indexing your vector elements or list elements, here also you can do the same thing by specifying your object of factor, that is the name. Let's say here we are having gender. So gender of, let's say suppose 3. So this will give you the third element, not third. So it will simply, let me just revise, ma'am. There are so many concepts. Yeah. So here, if I'm doing gender of 3, it will give you third element along with the levels as well. So here, by default, the levels will always get displayed. The same way that you are using for vector and list, you are using indexing over here. So if now this was about just I want to access the single element at a time. Now if suppose I want to access the multiple elements at a time. So I will create a vector for those elements. So here suppose I want to access second element and fourth element. So that access I will have to provide in the form of a vector. So I will use C function as an index. So here gender of, so gender of C of 2 comma 4. So here second and fourth element along with its level will get printed. If I just simply try to print gender of 2 comma 4 without using C function, so it won't be accessed. You will get an error. So whenever you are trying to access factor elements, here also you will have to specify. In case of multiple elements, you have to specify a vector, because whatever elements will be extracted, that you will have to be you will have to specify it in the form of vector only. This concept is similar to creating a slice of few of the elements. Okay, that's sort about accessing the elements. As compared to other data structures also, here also for factors also we can modify particular elements. So for example, let's say suppose for this gender data I want to modify the second element, which is male. I want to exchange this with female value. So gender of 2 I am setting as female. So here if I now try to print what are the contents of gender, so it will be modified. So this is what about the modification of factor. Okay, let's see how we can add a new level to the existing factor data. Because many times when we have downloaded some data from data set, and we want to add some new level if some level is missing inside. So here we can have, or we can add a new level to the existing data. So here for gender data, for gender factor we have 4 elements and levels as 2. And we have created like manually we have already created the third level as transgender over here. Now I can change this level, this 3 level into one more one. So it is like again I'm just specifying or adding a new level to the gender data with the help of levels function. So I'm setting levels of whatever data, whatever factor we want to create a new level for, that as argument. So levels of gender I want to change. So this is to be assigned by creating a new vector, and that vector will be now having 2 arguments. First argument for create function will be your existing levels. So existing levels is extracted by levels of gender. So this will become my first argument. And second argument will be whatever new additional level you want to specify, that you will have to specify in double quotes. So this is my command for that. So levels of gender is equals to C of levels of gender comma new level. So that is other I want to create. So this is how. Now if I check levels of gender now, so it should display you 4 different levels. We have quitted Arna previously. Okay. We have here only the three levels have been displayed because we just have quitted our in between. So it will just consider now in sequence that factor was created for female, male, male and female. So distinct two levels were created, that is female and male only. And वो जो हमने ट्रांसजेंडर ऐड किया था वो प्रीवियस सेशन में किया था. So that is not available now. Hence only the two levels were available for gender data. And as we have specified, this author has to be new level. Hence female, male and author, these levels have been now created for gender data, and that is assigned. So this is how you can change or add a new level to the existing factor data. This is one more example that how we can create a factor. Okay, now factors in a data frame. So this is another data structure, that is data frames. Whenever we want to create a data frame, so always factors come into picture. So first we have to create a vector, then we have to convert it into a factor, then we have to use that factor as a data frame. So let's see an example for this, how we can create a data frame. So this is new concept now, that is the last data structure of R. I'll just clear the screen. Okay, factors in a data frame. So this is about the data frame that is similar to a two-dimensional array with some columns and rows, which are having some values that denote some variables, and rows are having some values that are referring to a particular column. Here we have to just see some concepts that the column names are compulsory and they can't be empty whenever we are dealing with data frame, as in the form of when we have seen the matrix, like whenever we try to access the matrix elements, or we try to create a matrix, like we can omit the referring of rows values or column values, but whenever we are dealing with data frames, now here specifying column names is compulsory, it can't be omitted, that is the first thing. And unique name should be assigned to each and every row. The data frames data, it can be only of three types. It can be a factor, it can be a numeric, or it can be a character. The same number of data items must be present in each column. So that is the important thing whenever we are creating a data frame. Let's create a data frame. So let's say I want to create a data frame for some numeric values that denote some age numbers. So let's say this is one vector I have created initially. Then I want to specify, or I want to have some data about salaries as well. So I will have another vector which will denote salaries. Let's say now I want to specify the gender as well. So I will create a vector to denote genders. Now what I want, whatever vectors I have created, I want these vectors to be a part of a data frame, and which is commonly called as employee, let's say. So I will use data frame function, and for this data frame, now I will pass age, salary and gender as arguments. So data frame for these three elements will be created, and which is assigned a name as employee. Now if I check the contents of employee, let's see what it has. whatever elements you specify as arguments to data frame, so the columns will be created for those. So age ka column, salaries a column, then genders column, and vectors are whatever vectors are holding the values for age, salary, and gender. So that will come along with this data frame. So this is how you can create a data frame. It's like a tabular data representation.
Jyoti ma'am, if we
Yes, ma'am.
try to print here the last line, it is giving me answer as false, not true. Can you please check it?
Which line, ma'am?
Print is dot factor employee dollar gender. The last line of this code.
Okay, because this, ma'am, has a column hai, this gender column of employee. We haven't specifically created a factor data for this. Hence, it is not factor.
No, but in the output below, it is showing as a true. Uh, on the
Okay,
link given. Yeah,
okay, fine.
please
We'll
try.
check. Let's. So we have created with this. We have printed employee. This last line you are talking about, na ma'am? That
Yes,
we
yes.
have extracted gender column for employee. Yes, it is not factor data, na ma'am. That's why it will give you false.
No, but in the output, on that link as well, they have mentioned it as a true. See the this thing. It's been mentioned as true. And it has been mentioned there on the link as well that whenever we are creating a data frame,
Hmm.
so the column of the data frame is a categorical data. And
Yes, it
hence
is
a factor
categorical
is
data.
automatically created. That is what written there.
Yes,
Hmm.
because data frame, whenever we are considering, by default it should be a factor.
Right, right. So I
Let's
was
check.
also just wondering why it is giving false. I
We
thought I
have we
missed.
have run all the commands, na?
Yeah.
I'm also getting false over here.
Hmm.
We'll have to figure out, man. I also don't know.
Yeah, yeah.
Okay, ma'am. That's what for today was. I plan to cover factor and how to create a data frame. That's it.
Okay, okay.
Yes. We'll just check on this. If anybody has answer for this, they can help each other. The one who is already using data frames, I think they can help us. We will
Are
find it
you
out,
going
ma'am.
to? Okay, fine, fine, Jyoti ma'am. No issues.
Yes, ma'am.
Yeah. Are you going to share the link to mark the attendance?
Yes, I will. I've given the attendance link, ma'am.
Yes, yes.
Yes.
Got it.
So we have completed with module 1 out of 4 modules, that is introduction to R, then data types of R, and all the data structures of R.